of the final day. Now, for this session, we do have a few videos, which, as I was just saying to the other panellists, the good thing about that is we can turn them off when it gets to the end of the time. But we're not going to do that. So, look, incredibly delighted to introduce one of our wonderful members who has been there with us for quite some time, working incredibly hard trying to accelerate biogas and biomethane in Australia, Jemena. And we were just having a bit of a conversation because I'm struggling to pronounce Suzie's last name. So we've decided that Suzie is renaming herself and that she is now Suzie Jacobson. Yes. Well, she was saying Jacko, but I thought maybe that's not appropriate for this audience, but we can go with that. So Suzie, thank you so much for supporting Australian Renewable Fuels Week and continuing to support Bioenergy Australia. We're absolutely delighted to work with you every single day, it feels like. So let's get on with the job. Welcome, Suzie.
Thank you, Shahana. So my name is Suzie Jakobovits, for those of you that do want to try and pronounce it, but don't. It's Hungarian and it means actually son of Jacob, hence the Jacobson. Anyway, look, I'm the General Manager of Renewable Gas at Jemena. Jemena is an energy infrastructure business. So much like AGIG, Vikram spoke before from AGIG, we own energy infrastructure around the country, across the north of Australia and down the eastern seaboard. Our energy infrastructure includes both gas and electricity. Unlike AGIG though, we're not getting into the production side of things. We move the energy, we move the electrons, we move the molecules around the country. So I should start, speaking of this great country of ours, I want to pay my respects and acknowledge the lands on which we stand today, the Gadigal country of the Eora Nation, I believe. We, at Jemena, many of you may have heard of the Malabar biomethane plant. So we actually do own and run Australia's only biomethane production facility. So we've partnered with Sydney Water at their Malabar wastewater treatment plant. We are capturing the gas from that, cleaning it up and injecting it into the network. So it is that demonstration plant, that proof point that this can be done. We see overseas in Europe, in the US, in Asia, many biomethane facilities, but in terms of proving to local policymakers and showing them that this can be done in an Australian context, we have that. So anyone who ever wants to come and visit the biomethane plant, we run regular site tours, so just reach out and let us know. You'll hear a lot more about Jemena a little bit later. I think I'm in the next panel, so I'll go into more detail about Jemena and what we're doing to try to support our customers to decarbonise. I want to do a bit of a shout out to Shahana and the team. This has been one of the best conferences I've been to in terms of the information that has been shared. I know it feels quite jam-packed. There's a lot of these 10-minute presentations, but the information sharing has been incredible, and the conversations that I've been seeing out during the breaks as well, that bringing together this industry really needs that cross-sectoral collaboration, and that's what I'm seeing and hearing in the conversations out there. So thank you very much to you and the team, to Georgie, Adele and Shannon, and as I was thinking through the team that we work very closely with, I realised Georgie, Adele, Shannon, gas. That's awesome. I'm hoping that's part of your recruitment strategy. Day one of this conference, we heard about the need for renewable fuels, those low-carbon liquid fuels, and we need that for the energy security. We did hear about the barriers to getting that market started. What you'll be hearing about today will be more about the renewable gas side of things and how we are on the precipice of actually having this renewable gas market starting, what I believe will be this year and very soon, but I'll talk more to that later. We've also heard some fabulous conversations about feedstock. The feedstock potential, the different types of feedstocks, ways to maximise the yield. We've heard about the investment considerations, price signals, the stable policy that's required, the social licence for it. Today we're going to go a little deeper on renewable gases specifically. We've already heard about the incredible significant emission reduction potential. We've heard that renewable gas is available now. It is 100% compatible with existing gas infrastructure, with existing equipment and appliances in businesses. And it's also, if you look at the Bioenergy Australia roadmap, it's actually the lowest cost energy source that can be produced from that biomass. So it's the lowest cost abatement. It's available now. Let's get it out there and be contributing to decarbonisation now. In the previous session today, we heard about the need for renewable gases in the industrial context, and we also heard more detail about the scale of that potential benefit. In this session now, we're going to hear more about how to upscale supply to meet demand. I think on the actual agenda, it talks about meeting global demand. I want to push back on that just a little. I think we need to keep it here in this country. We've got a lot of industry that requires that gaseous molecule, and so let's make sure that we meet the needs of our local industry to keep jobs in this country first, before we start supporting more broader decarbonisation. The next session that you'll hear after lunch is about the demand side. So it's really just, how are we ramping up and able to support both the supply and the demand side to really optimise this market. Back to this session though, we're going to hear from some overseas examples about the thriving markets in Europe and the US. We'll hear about the policies that have helped make those markets thrive and the innovations that have been developed. We're going to hear about treatments to maximise biogas production, the sort of co-product opportunities to optimise value, co-digestion opportunities to reduce risk, and examples of specific projects. So I now invite the panellists to come and share their insights, and as Shahana mentioned, a few of them will be on videos. So I think we have Thomas Wagner is in the building today. Excellent. Come on, Thomas. We'll invite you to come and share your insights. Thank you.
Well, I hope I'm not the only one actually in the room for the Q&A later. Thanks a lot, Shahana, for organizing this really great event. Also, shout out to Charlotte from the World Biogas Association. We've run into each other in several locations so far, and also tirelessly promoting the industry. And of course, to Jemena, the sponsor of this session. And I couldn't agree more. So I've been to a number of conferences, and the quality here is really, really outstanding. A lot of things we learned, and that's why I came here, to learn about the Australian market, and hopefully also share a little bit about our contribution that we might be able to provide. If you want to know about me, I will be around, so just ask me. I've been responsible in Southeast Asia for EnviTec Biogas for the last 8 years or so, and I'm in the nearest office, so that's why I was dispatched. We are actually based in Germany, about 20 plus years of experience so far. And we've been listed at Frankfurt Stock Exchange in 2007, so you can see the market in Europe is a bit advanced from Australia. You have actually listed biogas companies there. We do EPC for biogas plants, for gas upgrading systems, as well as own and operate our own plants. As you can see, we've built about 700 plus biogas plants worldwide, of which we operate roughly 90 ourselves, mostly in Germany and Italy. And besides me, there is another 685 people working for EnviTec worldwide. I first want to share a little bit 3 examples of plants that we have built in Europe, just to give you an idea what's going on elsewhere, in case you don't already know. So this, for example, is a waste processing biogas plant, so actual organic residues from industrial sources in France, generating biomethane. For all of these plants, we have YouTube walkthroughs. I'm not going to show them now, but I think the slides are going to be distributed, so you can just click the link and watch them in private or find them. I think our channel is EnviTec Biogas or something like that at YouTube. Another one is an agricultural biogas plant, so that means we are using manure. I believe also some energy crop, probably, yeah, grass silage, but mostly it's organic residues and manure processed in this plant, also feeding biomethane to the French grid. And then we have our largest plant, which is in northeast Germany, generating about 25 tons of bio-LNG per day. So that is on-site liquefaction, not grid injection and then liquefaction elsewhere. We also liquefy the carbon dioxide coming from the separation on that side. And we generate the power required to operate the whole thing also from biogas on that side. So obviously that's a pretty large biogas plant, but also it shows what scale is possible and happening elsewhere in the world. That LNG, by the way, is used as a long-distance trucking fuel in about 20 LNG filling stations that also we operate in Germany and France. So we control the whole supply chain from the biogas generation all the way to LNG distribution in this case. In fact, also most of the input material in that case is chicken manure. Our major shareholder is Europe's largest egg producer, so even that is in-house, if you like. Now, how to upscale biogas and biomethane. Like you said, the topic was for global demand, but doesn't really matter to us where the gas is ultimately used. I think I discussed it a couple of times talking to policymakers. Yes, of course, everybody would appreciate domestic offtake. However, until there's a willingness to pay a price, I encourage developers in Australia as well also to consider export markets if they pay better. Australia is already liquefying gas, so why not? And once there is a market domestically sufficiently large, then the assets are already here. So I don't think there's anything inherently bad about considering exporting the molecules. Sorry, that was a bit too fast. That should be the back button, yeah. So what are the 4 major things on the to-do list that I want to get across? One is, and probably the most important point is, we all need a predictable business case to make the investment. There are a couple of ways of doing that, but a predictable business case for the developers and operators and financiers is the most important aspect. Then economy of scale, of course, will help with pricing. I have a couple of things to say about that. Obviously, we need to get the gas to where the market is. So market access and the involved logistics is important. And then also a diversified revenue stream. Interestingly, it was just mentioned in the session before to also consider, I think it was Charlotte who raised it, talking about the fertilizer, which is a possible additional income stream, and there are others. I have a slide on that as well. So talking about the predictable business case. I think the example of France was raised before. Maybe I make the point again. What you see on the left side is the distribution of gas upgrading systems that we have brought to market so far. So EnviTec is our brand name for methane CO2 separation equipment. And you can see probably it's more than 1/3. I can't read the number to be, there is none. Yeah, it's more than 1/3 of the gas upgrading plants went to France. And you can see on the right side the overall growth in the French market over the last 3 years until 2020. Last 4 years, sorry, 2000 until 2024, 2020 until 2024. You can see a steep curve. Now we are last year at about 700 plants. That's not us, that's overall market. And I heard 1,200 under development, somebody mentioned earlier. Why is that? Well, there is a feed-in tariff for biogas in France, for renewable biogas. The price is 30 euros. Well, I thought I come to an MMBTU country. I'm not, and I'm glad to hear that you actually used gigajoule, much appreciated, but that's about the same. So 1 MMBTU is almost, I think it's 5% different from gigajoule. So it's about 30 euros, not Australian dollars, per gigajoule in France. It doesn't have to be that much, but obviously the better the price, the faster the development. Second, we get long-term contracts. So it's not a spot market where we have uncertainty about prices in the near or long future. There are clear national targets. In the case of France, it's 10% of renewable gas until 2030. So those are targets that are actually followed up on. So it's not, as yesterday or on the first day, I think there was talk about how we have targets for 2050, but not for next year. And that's always somebody else's problem if we talk about 2050. And simplified procedures, also that was raised. Predictable business case during the development phase and regarding the income, that's key. Like I say, it doesn't have to be 30 euros per gigajoule, but that's obviously nice and proven to help. Economy of scale. Biogas plants actually don't have that much, I'm talking about the digestion part now, don't really have that much scaling effect, to be honest. So there is, of course, very small plants relative have high specific cost, but once you reach 1, 2, 3 megawatt, we get into replication usually. The real scaling effect is on the downstream side. So the gas upgrading, the gas utilization like bio-LNG, biomethanol and other options, that's where we have real scaling effects. Advanced membrane technology, so the efficiency of the membranes for separating CO2 and methane has helped a lot over the last few years. Then custom design of the upgrading technology and the biogas plants is important to provide large-scale units. LNG and methanol, I mentioned it before, those help with logistics. I'm getting there in the next slide. Grid access is really critical for scaling, not only to provide enough offtake for the biogas plant itself, but also to provide enough supply from a number of biogas plants to large users. And a national registry, and I hear there is already a registry, and we all expect it to be linked to the carbon emission trading system in Australia, hopefully within the next few weeks. So that's very encouraging and necessary for transporting or virtually transporting renewable properties of gas from one location to the other through the grid, or even from one grid section to a disconnected other grid section within the same country. Here are two examples for economy of scale. I already showed you the bio-LNG and liquid CO2 plant that we have in Germany, in northeast Germany. Another example is evolving in Malaysia right now. I'm mentioning it because it has been on the news. So a developer is planning a bio-LNG bunkering hub near Singapore, and that will be supplied by national gas pipeline throughout Peninsular Malaysia to provide renewable bunker LNG. So that means not export LNG, but actual fuel LNG for ocean-going shipping. Mostly driven again by European regulations where we have emission targets on shipping that is going to or from the European Union. By the way, with a carbon price of about 100 euros per ton. Now, gas market access. After upgrading the gas, we can transport it by truck using CNG, but that is only for a limited distance because of the relatively low energy density of bio-CNG, so at about 250 bar. Let's say until maybe 50, 100 kilometers, we can talk about that. But beyond that, we need other means. Grid access, already evolving in Australia. Bio-LNG and biomethanol, I want to quickly raise awareness about why that is significant. Both are easily transportable, and well, cost efficient to transport, I should say, especially biomethanol is easy to transport as well. The big benefit is we can produce those in existing facilities on mass balance basis. So it doesn't necessarily have to be a dedicated LNG plant as in our Bioenergy plant in Güstrow. Once the gas is in the grid, we can use existing LNG facilities or existing biomethanol plants to convert biomethane to bio-LNG or biomethanol on a mass balance basis, and then access any market that's accessible to biomethanol or to bio-LNG. Now about the diversified revenue streams. Of course, we have the biomethane, but beside that, every biogas upgrading plant is also producing almost an equivalent volume of CO2 at a very high purity. Somebody mentioned it's the cheapest way to capture CO2. I'm not an expert on that, but basically it should be true because the CO2 coming from our plants right now is free. Most CO2 is actually vented, which is okay because it's carbon neutral CO2, so it's organic CO2 as well. But obviously it would be much better to use it and either produce carbon negative biomethane or, well, abate CO2 in other fossil utilizations. In the plant in Güstrow, that bio-LNG plant, for example, we produce food-grade liquid CO2, which is going to the beverage market. It could be used for power-to-X projects as a carbon source. It's basically freely available, highly concentrated, I think by default about 95+% CO2. Of course, that could be improved if needed. To whoever has a good case. And it drives me nuts, frankly, when I see direct air capture CO2 projects. I wonder who is paying for that if nobody is even willing to take the CO2 we already have at a high quality at every biogas plant. Another one is gate fees, very important factor for waste processing biogas plants. That obviously helps to support the biogas anaerobic digestion factor. Somebody mentioned that's an important project, a factor, for example, in the United Kingdom, where we have limitations on organic waste going to landfill. Fertilizer, very much so. Already, digestate is almost always going back to farms. Usually it's priced into the biomass supply coming from the farm. But there are also quite a few locations where the fertilizer is indeed sold. One of our clients in China, for example, actually has a biofertilizer plant directly attached to their biogas plant. So that's another possible income stream. And then we have methane capture potential. I think probably here the most obvious one would be landfill. Others are manure ponds, where you currently have methane emissions coming from whatever biomass is available and avoid that emission by capturing the biogas and then producing biomethane, for example. So that's an additional income stream, perhaps for carbon credits, depending on the jurisdiction you're working in. Now, what can EnviTec contribute to accelerating the development here? So, of course, we have 20+ years of experience. We have built 700 plants. We are operating 90 biogas plants. And, of course, we are happy to share the experience that we have gathered there with anybody wanting to work with us on project development, on feasibility studies, and so on. And also that's why I'm here and going to a lot of other conferences in the southeastern part of this world. Then obviously we can provide our proven upgrading and digestion technology, as well as provide customized solutions, for example, for large-scale or also very small-scale projects, for on-farm fuel production projects. So all of these things can be custom designed, and we would be a partner with experience of large-scale deployment globally. So we have built plants large-scale in France, in the United States, in China, and of course everywhere in Europe. Now, what got us interested here? And that would be that Australia at least is a developed industrial nation, not so much in the biogas space, but in general. And that's helpful for us because that means that expectations in the quality, the efficiency, and the safety features of the product are in line with, what we would want to deploy. We do have decarbonization targets in Australia, so that's helpful. Obviously, now the question is, what is the money going where the mouth is or not? We'll see about that. I wasn't too encouraged by what I heard in response to my question earlier, but maybe that would have been the answer anywhere in the world, and it's up to the voters and the regulators to help out the industry with making good decisions there. We do see an emerging market here. So biogas obviously is not saturated. There's one biomethane plant in existence, so obviously there's a lot of space for new development, which we are happy to participate in. And we do see professional project development here. That's also not obvious and not the case in every market, and really key to fast deployment and development of the biogas industry here. Professional developers who know what they do, who know what the regulations are, and who can push for quick development. And that's perfectly on time. Thank you very much. And well, I'm here all day. Just let me know any questions, and I'm happy to discuss. Thank you.
Hello, everyone. It's very unfortunate that I couldn't be there with you today and experiencing the Renewable Gas Day. Unfortunately, circumstances have meant that I am in Brisbane and I've been preparing for Cyclone Alfred. It's an unfortunate series of events. I did want to take the opportunity to really thank Bioenergy Australia and the team, Shahana, Georgie, Shannon, and Adele, as well as others that have really supported Bioenergy Australia in getting to where we are today. I think it's been an amazing journey. I think we're only just getting started. It's amazing to see where the industry is going, and I'm super excited to see what this year brings in particular. I do want to thank for the opportunity to be able to share this presentation. I think it's really important that as a group that we really open up and share our lessons from our experiences both overseas and within Australia. Today, I'll be sharing some insights around what I hope we can utilise and leverage to help fast-track Australia's kind of biomethane developments. So for those that don't know LMS Energy, we are the leading biogas company in Australia. We have over 36 bioenergy facilities across the country within Australia, New Zealand, and the US. We currently abate over 5 million tonnes of CO2 annually and power over 250,000 homes with renewable energy. And we see our role across the whole circular economy. So we produce electricity generation from landfill gas to electricity. We also flare. So all of our sites, we kind of determine what's the best end use of our energy system, and some of that's putting it into the grid, some is for data centres, and others are just flaring because they just don't have enough gas. So we also have Harman Energy, which is another arm of our business that also works with our agricultural partners in delivering solutions for different industries, meat processing, dairy, to really support behind-the-meter generation, but also working in sugarcane, looking at developing biogas to biomethane and other fuel sources. It's exciting to see where we're going as a business, and we see biomethane really playing a significant role to support our future work in this space as we continue to abate methane. Now, I just want to give a bit of a context on where the global market is. It is growing significantly at around 20% annually, with production reaching 9.5 billion cubic metres of biomethane. That is a significant volume of gas comparatively. It's over 370 petajoules. For perspective, we currently are producing 90 TJs or 0.09 petajoules, thanks to the Malabar Biomethane Project. What I really want to know is how can we learn from international markets to fast-track our own industry? This is a developed, entrenched industry worldwide. We need to be able to leverage that and maximise it to fast-track our developments. Now, I'm sure from today, and unfortunately I wasn't there, a lot of people are talking, and yesterday, about kind of what people internationally are doing. And you have organisations like the European Biogas Association, the World Biogas Association, that have really started to document best practice, as well as the Biomethane Industry Partnership, who've released fantastic information to help support really the growth of the industry in those countries. And it's fantastic to see. And we can really work with those international partners, which we are at the moment, to fast track our own sector. We don't want to make the same mistakes. And what I've noticed in doing a project, in particular in the US, is there are hurdles. It is challenging, but the market in the US has created an opportunity. And although it is challenging at the moment in terms of from a political perspective, there is a lot of unknowns with the new government. Looking at the positives that we're looking at now and how that US has sustained explosive growth, you're looking at the RFS, the Renewable Fuel Standard. Now that provides, at the moment, as of last week, around about $28 US a gigajoule. Now you don't get that. Long-term offtakes are really, really important, and they're not going to obviously pay that amount. But those D3 RIN credits, which I'm sure James will get to speak on after myself, are really fantastic at being able to support the project. So that market mechanism has been really important. You have the California Low Carbon Fuel Standard, providing kind of that additional revenue stream if you go down that path for dairy in particular and other agricultural-based products. Targeted investment credit schemes. So renewable natural gas, as it's called in the US, was really targeted through the IRA. And those investment tax credits really provided a big opportunity to be able to deploy large amounts of capital and get those tax credits back. Now, there are certain requirements. So you have to achieve certain usages of US material. You have to use US employment. It's a great opportunity to really build industry. And just to touch on our project, we're looking at a 4,000 SCFM, or roughly 1 petajoule equivalent facility, and we're looking to inject into an existing state pipeline. So a really exciting project. We're leveraging mature regulatory environment, also purely established technical standards, and also really experienced industry. So a lot of the conversations we're having, you're not introducing what biomethane is or RNG. It's, let's just get this done. Like, we know what we need to do. We've done this many times before. We're talking to developers that have built 20 to 30 of these facilities. It is not new. And that's fantastic. It's really nice and refreshing. And I hope that one day we're in that same position. And hopefully it's not too soon. So there are some lessons learned that as part of the work that we have been doing. Commercially, long-term offtakes are so important. Really being able to lower the risk profile with greater than kind of 7-10-year deals is really important. It helps with financing. It helps in terms of providing a bit of confidence around where we're heading. Now, you don't want to put investment into a project that potentially you don't know where that is in 10 years' time. Long-term offtakes really provide surety to investors that they know what the long-term kind of profitability is going to be for those facilities. Technically, the design is critical. Understanding your pre-treatment systems, your nitrogen removal units, your CO2 systems, how they integrate with each other and the different types of technology is really important. And also how well they're improving that existing technology. It's fantastic to see the development is only growing. Prioritising gas quality and facility uptime. Facility uptime, the more you have the facility operating, the more biomethane or RNG you produce. Now, I'll just touch on Europe briefly. We have been doing a little bit of work in that sector and also have a few partners on a couple of projects. But they've got such valuable information, and I find myself communicating with some of our European counterparts on just project experience and lessons learned. They've got over 50% of existing global biomethane production and have been doing that for the past almost 2 decades. And it's really led by France, Germany, Italy, Denmark, and the UK. But we're seeing significant growth continue across Europe, which is fantastic to see. And that's the key policy drivers around the ambitious RED II targets, feed-in tariffs, tax incentives, grid injection, price premiums. Overall, the bioenergy industry, I've found internationally, is such a knowledge-sharing base. Everyone is so excited to get on the phone with you and have that conversation about how do you improve your facility, your anaerobic digestion process, which I think Europe do really, really well. And that's fantastic. And that's kind of one of those key lessons. So what we're seeing is, in particular for our ag projects, it's important to be able to gain that valuable experience on how do you manage those lessons learned. So diversifying feedstocks and the importance. Scale matters. The larger the facilities, they do achieve better economics, but they also have their own challenges. long-term offtake agreements with both feedstock and as well as your kind of offtake partners is really important. Also, potentially segregating your facility. So if you want to manage the feedstock as well as producing the biogas and potentially somebody else doing the upgrading process, kind of finding that balance, because there is a risk in each portion of that, and it's how you manage that. And it's also the modularity. I think it's really important as you move. Advanced monitoring systems. And I say that because process upsets are really important in how we manage those, and co-digestion models. I know I'm going to run out of time shortly, but Australia, we have made huge progress in the sector. We've got the Renewable Gas Guarantee of Origin scheme, which is now permanent. We've got the Renewable Gas Target consultation paper in Victoria that was released and submitted. New South Wales government also did that, the consultation as well, expanding the RFS. We've got industry standards through and code of practice through APGA, the AS4564 standard pushed through, Enger's market-based mechanism is under consultation. We are progressing significantly. Now, there is something that is missing, and I know we're doing consultation, but the policy still isn't there, and the regulatory frameworks still need to catch up. And what do we need to do that? We need to implement targets similar to the EU. We've seen it work. We know it works. Investments incentives. It worked really well in terms of building an internal industry within the US, specifically having requirements and obligations for Australian use. Develop clear policy roadmaps. Having a direction and where we see biomethane in the future is so important for investors in particular, and supportive regulations. But we don't just need it for the production. We also need to understand what are the regulations around feedstock, digestate, and other complex issues that surround the facilities. Approvals are going to be really important as these projects progress. How can we fast track approvals? And there's a lot of work being done internationally about how they can do that. But I guess the critical message here is supportive policy frameworks and clear targets, financial incentives, and regulatory certainty really provide a solid foundation for attracting investment and accelerating industry growth. And we have a unique opportunity to learn from the experience of decades of development internationally. Thank you. Hope you've been able to take something from today, and I'm very disappointed that I couldn't be with you all down there in Sydney, and I look forward to catching up with everyone when we do next meet. And I'm sure we will shortly. Thank you.
Hello all, it's James Harman coming to you from Brisbane. Unfortunately, I've been grounded by Cyclone Alfred. It's literally blowing a gale outside at the moment as I record this. And I'd love to be there with you in Sydney at Australian Renewable Fuels Week, but with as many of you as possible soon. So what I'm going to be talking about today is a whistle-stop run-through of US renewable gas projects and the policies enabling their success. So today I'll focus on the emergence of a booming and thriving North American renewable gas market, how it got there, and what the lessons might be for Australia. So who is EDL? We're a leading global producer of sustainable distributed energy. We were established in Australia in the late 1980s, and we're headquartered in Brisbane. We've grown and diversified to now operate 81 power stations and renewable gas plants across 5 countries, 3 continents, and we have capacity to sell over 1 gigawatt of power into 16 different markets. In Australia, we have 44 sites across a range of different sectors, including remote hybrid renewable microgrids in remote areas of Australia. We have gas-fired power stations, LNG, power generators fuelled by waste coal mine gas and landfill gas. And across Europe, in the UK, Greece, we have landfill gas to electricity generation, where we've been supplying reliable renewable energy to customers for more than 20 years. In North America, we're now in the top 5 landfill gas to clean energy producers in the US. We have over 150 megawatts of renewable baseload power and produce about 15,000 MMBTU a day, or gigajoules a day of renewable natural gas, which adds up to about 7 petajoules per year of renewable gas. We entered the US in 1997 and Canada in the last few years, and through a series of acquisitions, we've established a base of 21 landfill gas to clean energy facilities, including 1 in Canada, and now 5 renewable gas plants, as you can see on the map here, spread across the US. It started in 2020 in Indianapolis with our Indy High BTU RNG facility, and we've since worked with various waste companies to convert existing landfill gas sites to biomethane facilities, at Wood Road in Michigan, Testament in Texas, and now 2 newer sites, and 2 of the largest renewable gas plants in the US, Limestone and Lorraine, both in Ohio. So I'm kind of preaching to the converted on this, but what is biomethane, what is RNG, and why is it such a great green fuel? Well, this slide kind of sets it out. There's many uses of it. It's a waste product. It's derived from organic waste, and then renewable gas is processed to pipeline quality standards. And there's a cost in doing that, and that's why these frameworks and policies need to support the industry in helping to decarbonise particularly hard to electrify processes and transport. It's directly compatible with existing pipelines, it's fungible with natural gas, and it can be used in existing pipelines, existing appliances, and existing industrial processes that use natural gas. So it avoids expensive upgrades for networks, households, businesses and industry. In 2023, 79% of all gas used in transport in the US was from biomethane, and this is quite extraordinary. Renewable gas is used in CNG and LNG heavy vehicles across the US, and 79% of all gas used in transport was from biomethane just a couple of years ago, and it's getting closer to almost 100% now. And in 2023, that offset 7 million tonnes of CO2, or almost 3 billion litres of diesel didn't need to be burnt. A perfect example of how this works is in San Antonio, Texas, where biomethane produced at our Testament facility fuels a fleet of 500 council buses for San Antonio Council, providing a great circular economy using waste gases to help fuel the council buses in San Antonio. So how's this happened? It's happened on the back of supportive policies. It's an amazing achievement, largely due to market incentivisation through the right regulatory frameworks. These set clear long-term targets, provide flexible mechanisms so markets can grow without jeopardising supply or demand. And I'll start with the big one, the Renewable Fuel Standard, or the RFS, which is the basis for renewable identification numbers, or RINs. This is a marketplace where it's basically polluter pays. Diesel refiners need to buy green credits to offset the carbon that comes from the diesel refining, and companies like EDL and others in our sector produce these RINs through producing renewable natural gas, and the polluter buys these green credits from us to offset their carbon emissions. And they purchase the RINs and then they retire them to meet their carbon reduction obligations. And in terms of value, well, it costs a lot more to produce renewable gas than it does to produce natural gas. And so these credits need to have some material value to incentivise the production of green gas or renewable natural gas. But as an example, right now, the value of a RIN in the US is about $38 a gigajoule versus natural gas at about $2.50 a gigajoule. So that shows the differentiation in terms of the value of the product in the market. Another example of a supportive policy is RECs, landfill gas to electricity RECs, and there's various federal and state programs across the US associated with clean energy, which the RECs are tradable commodities and their value varies from state to state. But right now in Pennsylvania, for instance, where we produce power from landfill gas, power is selling for about $45 a megawatt hour for the black, and the REC about $30 a megawatt hour, so a total of about $75 a megawatt hour for power supported by these types of programs. Another supportive policy is the Low Carbon Fuel Standard, and 3 states have implemented legislation to reduce greenhouse gas emissions, all based on fuel carbon intensity. The prices of these credits can be quite volatile. In the past they range from $30 to about $200, sitting now at about $75. California really led the way in 2007 with a low carbon fuel standard. Oregon followed in 2009, Washington in 2023, and there's another 12 states that either have LCFS legislation under consideration or bills introduced. So an exciting space, and we're going to see more and more of this happening across the US, but also in Canada, where British Columbia formalised an LCFS early last year, and Canada is also introducing clean fuel regulations that will apply to RNG and clean energy. Another example of a policy is CARB, the California Air Resources Board Greenhouse Gas Credits, a system within California's advanced clean car regulation, and again, California really leading the way in this space. Credits are generated by car manufacturers who produce vehicles exceeding the state's mandated emission standards, allowing them to be sold to manufacturers who fall short of these standards, essentially incentivising the production of cleaner vehicles and reducing overall emissions from cars across California. And the last one on this page is the Canadian Fuel Regulations, or the CFR, and these increase incentives for development and adoption of cleaner fuels, technologies and processes. They require liquid fossil fuel suppliers, i.e. gasoline and diesel, to reduce carbon intensity. And that's happening at the moment, and it's leading to a decrease of 15% in carbon intensity of those fuels, anticipated by 2030. That's below 2016 levels. One that's not on this page, but it really has been a game changer for renewable natural gas particularly, and has seen an incredible boom in the construction and operation of renewable gas plants across the US, is the Inflation Reduction Act introduced by the Biden administration. But the Inflation Reduction Act has allowed developers of RNG plants in certain periods of time to claim income tax credits against the capital cost of developing these projects. And that's helped fuel the boom really in construction in recent years, and EDL has benefited to a small degree from that as well. So what's been happening in the RNG space in the US? Well, the trajectory of growth over the last 5 years is quite incredible, really, as you can see from this graph. By the end of this year, the industry expects to see more than 500 biomethane facilities in operation across the US. There's many more projects under construction or in development, and that growth will continue over coming years. But I expect we'll see a bit of a slowdown, and the key reason for that is that supply is saturating the market, and there's limited demand, particularly in the transport market, for renewable gas. So current annual production of RNG is about 120 million MMBTU, or close to 120 million gigajoules, with demand just below that level. So, as I said, the renewable transport market is becoming saturated, but that's really led to the emergence of another market that's thriving right now, and that's the voluntary market, where large corporates who want to purchase renewable gas for hard to electrify industrial processes, or for their own carbon footprint, for large corporates who consume gas even in heating buildings, heating offices, certainly key in industrial processes as well. These companies who want to offset their emissions have the option to voluntarily purchase renewable natural gas, and it can be certified as validly renewable. And several corporates and utilities across the US and Canada participate in this market, driven by supportive policies such as the one I've got on this page, the Oregon Voluntary RNG Goals. And in fact, one of EDL's customers in Oregon buys significant volumes of RNG from us and is able to spread the cost to customers through its regulated asset. So that voluntary market is really starting to set the price. And an RNG industry has incredible benefits across the whole economy. The biomethane sector across the US supports over 55,000 jobs and contributes more than $7 billion to GDP per year. So in conclusion, the US RNG biomethane industry has been a major success story, and there are so many lessons here for Australia that we can borrow from without having to reinvent the wheel. We have the feedstock, we have the demand. In fact, our domestic gas market's crying out for more supply. What we're missing is a supportive regulatory framework to underpin investment in renewable gas and market creation activities. At a minimum, we need a renewable gas target similar to the existing renewable energy target, the RET, that's been so successful in Australia, and the low carbon fuel standards in the US. It'd be a great solid starting point where the polluter pays. A renewable gas target would work with fossil fuel gas companies needing to produce a certain fraction of their production as renewable gas, and if they're not able to produce it themselves, then they can buy credits from those who are able to produce it to offset some of the carbon of the fossil fuel gas that they produce. I'm going to leave it there. There are so many lessons that could be learned, and I could talk about this for a long, long time, but this is a very short presentation. The key message, I guess, is that this industry will only thrive in Australia with supportive regulatory framework and policies. That's been seen in the US, it's been seen in Europe as well, where we operate. But our experience in the US is that if you get the policies in place, you get the right framework in place, then the market will follow and can lead to a buoyant and thriving industry such as we participate in the US. I look forward to continuing to support the development of that industry in Australia and hope to be able to come back and talk about the exciting projects that are being built in Australia to produce renewable gas to help decarbonise many sectors across Australia, including industry, transport and others. It's been my pleasure to talk to you. Apologies it's a recording. Wish I could be there with you in person. Wish you all the best for the remainder of Renewable Fuels Week. Thank you.
Hi everyone, good morning to all of you. My name is Disong. I'm from Anaergia. I'm very pleasure to be here, and I also want to thank the organizer for organizing such an excellent event. Now the topic is about maximizing biogas generation, and I think it's a very meaningful topic because for all the owners of any biogas asset, we want to achieve the best economic scale to go for the best return from investment. So today I want to share with you two solutions that we have that can help us achieve this objective. Now just a quick overview about Anaergia. Anaergia is a technology company, so we own a big portfolio of technologies. Use the technology, we process all the type of waste material that you can see on the left-hand side and turn them into renewable power or renewable gas and organic fertilizer. So all the technology basically are the enabler for this conversion. As a group, all the technologies we have, we will start from the waste receiving, pre-treatment, very important, and go into anaerobic digestion and processing of the gas, either into power or into renewable gas. We also have a growth technology that handle the digestate treatment. Now overall as a group, we have completed more than 1,700 either plants or subsystems. So a lot of track records and knowledge and experience. We have global operations, so in Italy, UK, and Africa. I'm from Singapore. And we also have operations in USA and Canada. Our fundamental business model, basically we supply the technology package to our customer. It will typically include the engineering design, process guarantee, and the key equipment we needed for the project. Upon request, we also provide service on OEM, and for case-by-case basis, we may own, invest, and operate a biogas asset. It could be greenfield or brownfield. Now, one of the two solutions we have, the first one is about pretreatment, which is related to feedstock. I think this is very important. I think many people have emphasized it. For a biogas power plant, you can have many different types of possible feedstocks. It will range from a very clean material to be very challenging material such as MSW. If your plant is able to accept different kinds of waste and you have your pretreatment system versatile enough to handle all of them, you will expand your feedstock supply base. So in this case, we have this technology called organic extrusion press. It's a high-pressure extrusion-based technology. What it does is that it can accept very, we call polluted waste. Yeah, it's actually like a lot of contaminations, even for material like MSW. And after the process, we will have one wet fraction, and that's what we are targeting for. That's the material for AD plant. And the reject fraction, which is the dry fraction. Now, one additional information for the Australia market is that FOGO. This equipment also is suitable for processing on FOGO. So you accept the waste in your AD plant and you treat them. This technology also enables another possibility that you set up an off-site organic recovery facility. You accept the waste locally, you recover the organic, and you bring the organic material to a centralized AD plant. So we have additional feedstock on top of the waste that you're receiving in your AD plant. You also achieve another objective by doing so, that you divert the organic from landfill. So if you have landfill tax or you want to reduce emission from landfill, this is another additional benefit. Just on the FOGO topic, on the left-hand side, the picture is about the mixture of food waste and the garden waste. After the ORS processing, what you get, the center is the organic fraction and dry fraction on the right-hand side. Now, if we talk about the quality of biofertilizer, then we need to control the quality of the organic in the digester. We have this technology called polishing system. This step removes all the small flake of plastics. Another step to remove all the grit and sands, including glass particles from the organic. So after this two-step polishing, you will get a very good organic fraction into digester, guarantee your smooth operation of digester, and you will get a very good quality of organic cake out of the digester for further use as fertilizer. So this first solution, make more feedstock available for the AD plant. Second solution, how can we make more biogas out of the existing digester? A solution we call Omnivore. It's enabled by using a high solid content digestion technology. Just a simple chart, I use a wastewater treatment plant digester as an example. When you increase the solid content of your digester, the same digester will be able to take in more waste and generate more biogas. And that allows you to take in additional organic waste from, for example, the off-site organic recovery facility I showed just now. A lot of benefits of doing so: additional capacity out of your existing plant, and you don't build additional digesters, so lower capex, less volume of material to handle, to mix, to pump, to heat, so operation costs will be lower. Additional income for waste coming into your facility, gate fee, more power, more biogas. There's a group of technology that enable this solution, and one of the key technology is this mixing technology called a PSM mixer. It's a submersible mixer and a slow speed, so it has very high torque, and it can handle material with very high solid content, viscous material. It's installed on a guarded pole, so we can adjust the height of the mixer at different stages of operation. It also comes with a service box on the top. What it allows you to do is to carry out all the maintenance and repair work of the mixer while your digester is still operating, generating biogas continuously. It's very energy efficient mixing technology also. Now I just want to show some case study pictures, interesting. This is a plant we have in Singapore that deal with, have installation of the OREX and the polishing system, and also with co-digestion, with best and maximum biogas generation. Actually, co-digestion also benefits chemically in terms of the material that you use. This is another plant we did in Italy. You can see the 4 digesters there. We did a retrofitting for one of the digester. Now this digester is able to handle the material that used to be handled by 3 of the digesters. So you can see the other 2 digesters right now are empty. And the benefit for the owner is that lower capex cost and lower operation cost. There's another project reference we have, but I want to show this one. It's interesting. This is a SoCal biomethane plant that we own and operate. What you can see here is that at the center, there are 2 existing digesters. We did the retrofitting and technology upgrading. And now, the facility is allowed to take in additional organic waste from external sources. So we can see the facility at number 1. That's the one we installed to taking additional organic by truck. We also installed the biogas upgrading system that's on the right-hand side. So this is able to produce about 320,000 MMBTU per year. I don't have a picture here, but by doing all this off-site organic recovery and centralized AD, we are also operating one of the biggest biomethane facility in California and USA. It takes about 700 tons per day of organic material and produce 1 million MMBTU per year. Yep, so 2 solutions. One is to maximize the feedstock, and second is to maximize the production capacity of the existing digester. That's the key message for me today. Thank you very much.
Hello, everyone. First of all, I would like to thank the organizing committee for the opportunity to present my work. It's really very unfortunate that I'm not able to attend the conference this time. So in my presentation, I will introduce our new project funded by the Gold Coast City Council and the CRC RACE, focusing on the ammonia treatment in the landfill leachate wastewater. I would like to first briefly introduce myself. My name is Yang Liu. I'm a professor in environmental engineering at the Queensland University of Technology. I'm relatively new here to Australia. I only just joined QUT about 18 months ago at the end of 2023. Before I joined QUT, I was a professor at the University of Alberta in Canada for over 15 years. So my work is mainly around the development and optimization of aerobic and anaerobic bioreactor systems for waste and wastewater treatment, biogas and nutrient recovery, water reuse, and biogas purification. So in my lab, we often operate multiple bioreactors in parallel, each with different design and operation conditions to refine and optimize the treatment efficiency. And we'll conduct lots of molecular biology work, try to link engineering design and microbial ecology, and consider how we can optimize the engineering design and control for the selection of more active microorganisms in the bioreactors. Some of the work or technology we've developed has already been successfully demonstrated at a large scale. So for the project I would like to introduce today, that is around the ammonia removal from the landfill leachate, especially for the landfill with the leachate recirculation. So the landfill leachate recirculation is actually a very commonly used approach to maintain moisture level and to improve waste degradation. However, when we recirculate landfill leachate, we also concentrate the ammonia concentration in the landfill, and that will eventually inhibit methanogen activities. So in this project, we will assess the feasibility of applying the granular sludge reactor technology, we call it GSR, for high ammonia landfill leachate wastewater treatment. So the GSR process is this one-step biological treatment process that was actually developed by my own research group. So this technology is ideal for the high ammonia wastewater treatment. It is very energy efficient using the nitritation, animal oxynitritation pathway, and it has very low sludge wasting and maintenance requirements. We've already applied this process for a range of wastewater types. As you can see some examples in here. So in these graphs, we have the influent ammonia concentration in the dark green circles, and the empty circles of green circles are the effluent ammonia concentration. What you can see in here that under all conditions, we can achieve over 99% ammonia removal. And for some of the reactors, we've already operated those reactors for over 3 years, and we observed this very stable operation performance. And we also want to point out that in terms of the hydraulic retention time, we're using very low hydraulic retention time here. So the hydraulic retention time ranged from 5 hours to 8 hours, and the influent ammonia concentration ranged from around 200, 300 milligram per liter to over 1,000 milligram per liter. We've also demonstrated this process at the large scale. So this is one example for the GSR application for the municipal sludge digestate treatment. So in this particular case, we had ammonia concentration ranged from 800 to 1,200 milligram per liter. The 2 reactors, as shown in here, has a treatment capacity of 2 cubic meter per day. And if we look at the footprint, it's actually a very compact system, including with the control panel here, as well as all the pumps and other control systems. The total complete footprint is only 2 meter by 2.5 meter. We operated the reactors with the HRT of 6 to 8 hours under room temperature conditions of about 20-degree conditions, and we were able to achieve quite stable reactor ammonia removal efficiency. So the core of this technology is really about selecting the highly active ammonia oxidizing bacteria, because bioreactor performance is usually very much determined by the microbiome in the bioreactors. What I'm showing here is just some examples of the ammonia, the optimization process. So the blue bars here shows the ammonia oxidizing capacity of the different bioreactor sludge. So that represents really the rate of the ammonia reduction, which is then normalized by the total biomass concentration. So if we start with the ammonia oxidizing bacteria activity in the activity sludge system, which is the C sludge for all the reactors, the ammonia oxidizing bacteria activity is really low. But then if we start to look at the optimization through the control of how we operate the reactor and the reactor configuration, then we can start to see by, for instance, implementing sequencing batch type of operation, we can select the more active ammonia oxidizing bacteria. And then if we start to control this oxygen concentration and the feeding strategy, then we can achieve this extremely high ammonia oxidizing bacterial activity that is 10 times higher as compared to the activity sludge activity. And in addition to the selection of highly active microorganisms, we also used engineering selection pressure to select or enrich the granular sludge. And the granular sludge, similar to the anaerobic granular sludge, can settle very fast. They have very high density and they're highly resistant towards toxicity. And therefore, they're ideal for high-strength wastewater treatment. So for this particular wastewater that we are treating now is the landfill leachate that has extremely high ammonia concentration. So what you can see that the average ammonia concentration is above 3,000 milligram per liter. We also have very high COD concentration. And therefore, when we started the reactor operation a few months ago, we thought we'll just operate additional reactors just to deal with this extremely high free ammonia concentration and high COD conditions. So we operated the 3 reactors. The first reactor was operated with the traditional GSR operation on how we would operate this type of systems previously. And then the R2 reactor, which was operated with the control of CN ratio. Essentially, we adjust the feeding strategy based on the COD concentration inside the reactor, and we allow the COT to degrade from through the denitrification before we add additional leachate into the bioreactor. And the third reactor was operated with the free ammonia level control inside the reactor in order to optimize the treatment performance. So from the performance data, we can see that R2 and R3 can completely remove ammonia from the landfill leachate wastewater, but we still are still in the process for optimizing the reactor operation. So if we take a look of the AOB activities from these reactors, the light blue bar represents ammonia oxidizing bacteria activity observed in our previous study. Although we haven't yet achieved the optimized AOB activity level, what you can see is that with the optimization with R2 and R3, these two reactors are able to support the selection and enrichment of highly active AOB. Based on all this, I would like to just to summarize. So effective management of digestate is crucial for the optimization of nutrient recovery and ensuring the environmental compliance for sustainable waste management. As we can see, that based on our laboratory study, our GSR has demonstrated a strong potential for reducing ammonia concentration from the high-strength landfill leachate with internal recirculation. And our aim is to complete the laboratory study this year and to set up pilot systems in 2026 next year, and we'll start the pilot testing and optimization. The last point I want to make is that the composition of digestate can really vary depending on the feedstock and the digestion conditions, and therefore in terms of the digestate management strategy development, it's very important to look into the other characteristics, and if needed, testing and optimization are often needed. So with all that, I would like to acknowledge the financial support from the City of Gold Coast, RIS CRC, and my ARC Future Fellowship. Thank you very much.
All right, everyone. Hi there, my name's Nick Lawrance. I'm the Engineering Manager at NALG, and I'd like to thank Bioenergy Australia for putting on such a great event this week. I've had a great time. And I'd like to take you through our journey of energising organics. So, and our journey of accelerating Australia's renewable gas generation. So, NALG quickly. Organics is our energy. Innovating the organics processing space is our business. Delivering sustainable solutions in the organics processing area is our mission. And I'll cover more of this later in the presentation. But making biogas happen, we hear it from Charlotte, and we want to pick up the gauntlet of actually delivering those biogas projects to Australia. So just a quick one on the executive team. This is a diverse group of people that are behind NALG. They are the people that have invested significantly in it and are true believers of the cause. Now that's no different from our management team. We have a multidisciplinary group with experience in organics and waste industry, bringing together decades of experience. So, our technologies, capabilities and partnerships. NALG bring together a unique combination of technologies, offering an industry-leading circular hybrid processing model. NALG started out in the aerated for and in-vessel composting systems, often known as IVCs. These systems are scalable, modular, and can accommodate small and large project requirements. In future years, NALG has partnership with Canadiva Innova, formerly known as Hitachi Zosen Innova, and with that bringing their full suite of technology that they offer, of which wet and dry anaerobic digestion. These are full package systems. They include all associated gas conditioning, upgrading and processing. These are tailored to best suit sites and the unique opportunities that they offer. To complete that loop is our carbonisation systems. These utilise a gasification process, outputting a high-quality biochar. Now, our capabilities are just beyond technology supply. We are actively involved in project development, design and engineering, construction, commissioning and operations. We've strategically partnered with these businesses below and others to make possible the facilities that we're now offering. So, just a quick look at the traditional Australian waste composting process, and this is what's happening with most FOGO waste in the country. It's a pretty simple process. Now, they're low cost, easy to manage. They do have a fast breakdown of organic material, typically suited to areas with larger sites. Now, issues with these is some of the recycling rates can be quite poor. We have contaminated oversize and legacy organics, which actually end up in landfills. We're net energy consumers, GHG gas emitters, affected by weather, and have a limited amount of food waste or types of food waste that they can accept. Now, this is we're losing huge value in the organics actually processed in this way. So, enter NALG's hybrid processing solution. So, we take a typical IBC system that we know. This is all associated process control, air handling and odour capture systems. We now add typically a dry AD system, giving us the process now of taking a wider range of organic materials and unlocking the valuable biogas generation for sites. With this biogas, we have a range of options available to the site. We have the opportunity of using a CHP or taking the gas away and upgrading to biomethane or CO2. A typical footprint on site, taking away the parasitic load, we are still net exporters. Now, this leaves out the final step, which is another important one, is the carbonisation. So there are difficult to digest and compost materials, and carbonisation completes the link. Now, using this, we now also have another diversified product that we can output from the site, being biochar. And now, just touched on before from our friends in Anaergia, facilities need versatility to be able to process a wide range of feedstocks. As an operator, having worked at facilities, this can change quite often. So when we're looking at an organics processing site, we see a dry AD system as the most advantageous. So as a dry AD, as the name would suggest, it digests material with high solids content without the need for significant liquid dilution. This provides the versatility to digest a diverse range of feedstocks, as we've shown up there before. All right, so just a quick look. This is the snapshot of our partner projects, and just to basically show this is quite successful and deployed technology overseas. 120 in-vessel composting units, 150 dry ADs, 500 plus wet AD systems, and 14 plus carbonisation systems. And just a quick snapshot to our current and completed projects. So NALG has several composting facilities successfully in operation around the country. We are in the development stage for developing AD and carbonisation sites. As many of the people in this room would be probably aware that developing these sites and projects is challenging, and I really look forward to that 4-month permitting time that Charlotte was talking about earlier. That would be fantastic. And with these projects, we offer various delivery models, so EPC, or in a recent project that we're in the development stage for the Mid-Coast region, will be a build, own and operate. Just basically showcasing our commitment to investing in our technology and backing it. These hybrid facilities, we have modular processing capacity, so sky's the limit, really, in terms of how much we could process on a site. So 2030 is fast approaching with FOGO mandates, and developing infrastructure for regions is going to be critical to meet these mandates. I'd like to thank everyone for their time, and this has been NALG's journey to energise organics. Thank you, and yeah, if you've got any questions, get in touch.
Good afternoon, guys. So I'm Joseph Oliver. I'm the Managing Director and Co-founder of Delorean Corporation. And I think to Suzie's point, I'm going to bring it back to Australia because I think that's the focus, obviously. And it's certainly the focus of ours. And thanks to Shahana and the Bioenergy team for inviting us to speak. So a little bit about Delorean for people that aren't across what we do. We're an Australian listed entity headed up by Delorean Corporation with 3 divisions, and our focus is build, own, operate. So for us, we've done a lot of lessons learned over the 12 years of existence. We've built award-winning facilities that we'll touch on shortly, but also we've heavily focused on what the commercial requirements are of delivering facilities in the Australian context. And that's where we've honed in to enable a pipeline. And we're going to talk through an announcement that we've got today as well. But across Delorean Corporation, over the 12 years, we've built up the engineering division that's built the successful facilities. We've got an infrastructure division that is focused on build, own, operate of Australian assets in the bioenergy space. And when we talk bioenergy, we are talking about anaerobic digestion, not landfills. And we've got an energy retail division that highly focuses on, it's got a retail licence nationally for electricity and also a Victorian gas licence as well. So across the journey, again with the commercial lens, we've designed, built and moved into operation multiple facilities, award-winning facilities that have really focused on how we convert organics and the different types of organics. We spoke a lot about agricultural residues, where that fits in the Australian context currently, in addition to commercial industrial organic waste, where we are predominantly focused, and then into that sort of municipal waste and that diversion of food organics, green organics, FOGO, from landfill. So as we look at the opportunity, and the circular economy of utilising a resource or changing the name of waste into a resource, there's over 40 million tonnes of organic waste in the Australian sector. 12 million tonnes of that is currently going to landfill. There's a national policy to halve the amount of organics going to landfill. We really need to stop organics going to landfill. It's not it's not in the circular economy. The circular economy is to utilise. So as we look at this bottom demographic, we can see that we're processing organic waste through a well-mature technology. We're not a tech play. We're here around a commercial lens. We develop facilities to give a commercial return to support investment into this sector. Our focus previously has been in the generation of electricity, mainly because of the offset of energy behind the meter has got the highest commercial value. But we're seeing a strong push, and the projects and case studies that we'll talk about shortly will highlight our sort of transition more into the green gas sector, where we not just see higher efficiencies, but better returns from being able to capture the biogenic CO2 side as well. So across our portfolio, we're heavily focused on pulling all of the levers to support the investment into this sector to really drive this sector forward. And we feel that we're starting to create a bit of a deflection point within the market when we talk about our pipeline that's across that. So obviously from waste, harness the energy, capture that in a green gas, generate the biogenic CO2, but also output a biofertiliser that is really key to that circular economy of driving waste from landfill, but also into energy. So where do we play a role? Look, we're heavily Australian focused. We're, as we highlighted, we're an Australian listed company that started here 12 years ago that is focused on the Australian market. And as a developer, we've had a lot of success in this space. But we've had to hone in on what our offering is by building the engineering division to deliver a commercial outcome, not a over-engineered outcome that doesn't align to the commercial proposition. So our pipeline of projects is across the bottom that we've spent a lot of capital. I think, again, making reference to Charlotte's point of getting that down from 3-4 years to 4 months, and let's put it as under $500,000 would be a really good outcome. We've deployed a lot of capital, seed capital, into our pipeline, and with the focus on gas, we see that with the SA and Vic project, that's starting to ramp up exponentially as we deliver more projects into this sector. So, we've got an announcement that was released today, and I'd just like to thank our partners with ARENA. We secured a $6.1 million grant towards our South Australian One project. So, yeah, so that's been a long journey. I think we've all put the work in, and I think the saying is there's no such thing as a free lunch, but we're getting there. Also, AGIG, they've supported us along the way with the South Australian project, and I believe this is going to be the first gas or biomethane project outside of the hydrogen projects that they're doing into AGIG's network. So, again, a great achievement. This project is in build, and I'll talk about the timeline shortly. We secured finance through our partners at Tanara, and we are into that construction phase. And we're a long way down the path with the offtakes, both from a biogenic CO2 and also from a biomethane upgrade perspective. So this facility in South Australia is in a place called Edinburgh Parks. It's about 15 k's out of the city. It's in a light industrial park. It's able to process organic waste with neighbours on all 4 sides. It's taken a little bit of time to get through the approval, but also reach FID, but we have broke ground. We've also expect to be generating first gas by this time next year. So that is well underway. Long lead items have been ordered. It will generate just short of, it's about 200 TJs per annum, so 200,000 gigajoules. We will be outputting just over 180 once we offset the parasitic load on site as well through the biogas generation. It's a 70,000 tonne facility. I think there was a couple of comments of, I think Lee highlighted a 12 petajoule offtake. 12 petajoules, I think, just in the scheme of things, is well over millions of tonnes, and I think we have to sort of bring ourselves back to the point of how big facilities are. I think Thomas had a slide up of a 150,000 tonne facility that was very large. So this is a 22,000 square metre site, and our focus is deploying this through to first gas, generating biogenic CO2 and methane into AGIG's grid in South Australia. Also, another case study is the Brickworks facility in Horsley Park, so sort of about 40 minutes outside of where we are now. This facility is focused on, and will be, again, another Australian first, to support the energy offtake behind the meter, and it will support Brickworks' manufacturing process in creating green bricks by reducing 50% of the emissions. I'm mindful of time, so I'll move through this as quick as I can. So we're pushing that through the development process. Again, that's been a costly, timely process, and it'd be great to get all of the agencies and policymakers on the same page, so that we can achieve this type of infrastructure that aligns to the decarbonisation pathway of the hard-to-abate sectors as well. So what does it mean? Well, collaboration is key. When we look at all of our projects, from offtakes to lining up all of the levers to enable a commercial return, is where we're heavily focused. So getting government, local communities, the industrial sector through to investors and suppliers all on the same page is where the projects need to start. and then successfully delivered all the way through, because we can't afford, as Charlotte again said, a failure in this nascent market that we've been pioneering for some time. So we're on a mission. We're heavily focused on transforming Australia's waste landscape. We recognise that there's energy challenges ahead, and also we see this as the greatest opportunity that Australia has. And I'll leave it there. Thank you.
Right. Hello, everyone. Scott Grierson is my name. I'm the CEO and Managing Director of emerging biogas developer Valorify. Thank you to the Bioenergy Australia team again. In some ways, it feels like Groundhog Day. We've done this many times, but there's definitely progress being achieved. So thank you for your continuing efforts, the whole team. So I'm going to talk a little bit from the hurt locker, I guess, as an emerging developer, and some of the challenges and things that we've had to consider along the way. Our paradigm is a little bit different in terms of the way we're going about trying to transform utility scale biogas in Australia, but I wanted to talk a little bit about co-product opportunities, because this is very, very important. Obviously, meeting the demands of the market, our paradigm or the way that we think about this is that industrial scale users need industrial scale solutions, right? So we're not talking about small scale plants here to decarbonise a Kooragang Island or a Boral Berrima kind of plant. We're talking multiple petajoules of renewable gas. The opportunity we have compared with the European Union, with no disrespect, where a lot of this technology, Thomas, has been incubated and carefully built up in terms of expertise, and even in North America over a long period of time, is that we can leapfrog. We've got this opportunity to kind of take a giant leap from where we are today. Let's face it, we're coming off a pretty low base to really learn the lessons, and I think that's really important. We need projects of scale. Biomethane delivered in front of the grid, because that's very much what we're chasing, is obviously supporting legislated emissions targets and such things as the safeguard mechanism. But we urgently need that recognition under NGES, and I think everybody would agree with me on that. So hopefully that's not far away. We see a big opportunity in gas power generation. If you look in the South Australian electricity market, for instance, one of the most highly penetrated asynchronous renewable markets in the world between wind and solar, but they still need gas firming generation, despite all of that, for sort of 5 to 10% of an annual generation cycle. So we see a way to decarbonise that most cost effectively with a biomethane product that can drop in. And then we see global interest rising in Bioenergy, and we've heard a lot of talk on that already, so I won't recap that, but particularly in the shipping sector through bunkering, which we think is a really exciting market, and a lot of demand in offshore markets for Bioenergy, where those transport applications are very well established. So if I look at the revenue stack, the bankability obviously of all your revenue streams in a biogas plant are very important. But the sad reality today, where we sit, is that domestic buyers in Australia, and Lee touched a little bit on this in his presentation earlier today, just unable to pay what Asian and EU type consumers will pay for the product. And anybody seen that Argus Media publication that's on the desk out the front there? The price for German biomethane in the market ranges from 90 to 120 euros per megawatt hour. So we're talking 40s to the low 50s Aussie dollars per gigajoule, right, for the product. And that's just a fact. It's a market reality. We can't avoid it. So the challenge is, in those markets, of course, there's also incentives and support, and, there's some fairly eye-watering numbers talking about the value of the abatement even in those markets over and above the actual methane molecule itself. So there's a lot of things to think about in how you monetise and bank the revenue streams in a project. Biomethane yield is also really important. Lee also touched on this morning that Australia is a very high-cost labour market. So automation and high yield is really, really critical to overcome some of the challenges of operational costs. So biogenic CO2, great opportunity, but it can be as much as 50% of the volume in your biogas stream. What are we going to do with it, right? Every biogas developer that I talk to in Australia has designs on selling food and beverage grade CO2. I'd like everybody in this room to start drinking a slab of Coca-Cola every week, because pretty quickly when you start getting into utility scale solutions, we're going to be producing way more biogenic CO2 than Australia's food manufacturing base can handle. So really, that's a good niche early market to get traction and to bank CO2 revenue. But for us, the sort of scales we're operating out in the hundreds of thousands, potentially at full scale per annum of biogenic CO2, we just can't really contemplate that over the longer term. There's a really exciting opportunity in synthetic hydrocarbons. Synthetic protein is emerging. And there's some really interesting plays around bioenergy, carbon capture and storage, and the growth of CDR markets around the world, where we're looking at net carbon reductions. Biofertiliser is part of the value equation here. It's really important to the circular economy element of the biogas story. But for us, we don't see that as a big driver of revenue. It's a big driver of value, but that does depend a little bit on your process configuration. I'll come to that. So what I'm going to share with you here is sort of call it a class 5 early sort of comparison that we did with some different technology vendors that at a very high level, take it slightly with a grain of salt, right? Because this is based on relatively imperfect information in the early days of investigations. But looking at specific vendors around the world that had experience with the class of feedstock that we're interested in, which is lignocellulosic straw in the cereal cropping sector. And you start to very quickly see that there are some fundamental challenges and limitations with the traditional mesophilic system. This is all calibrated, by the way, against a standardised output of 2 petajoules per annum. So you can see the varying differentiation of process inputs or feedstock inputs to get that same output, depending on different technologies and different plants. So huge variation between the mesophilic and thermophilic plant designs, for instance, in terms of feedstock inputs. But one of the interesting things that really struck us very early on in the discussions with potential project proponents was the scale of the digestate output. So if you look at a traditional mesophilic plant that has those sorts of scales of feedstock inputs, you're getting a very large amount of dry weight solids equivalent in the digestate stream. And a large multinational oil and gas plant, operator that we spoke to around investment said, well, this is not a biogas plant, this is a fertiliser plant masquerading as a biogas plant, right? So here we are talking about a 2 petajoule scale biogas plant, which is one of the largest, potentially certainly would be one of the largest in the Southern Hemisphere, and you're going to have to tack onto the back end of it one of the largest organics processing and handling facilities on the planet at the same time, and that for us was too much complexity. So we've gone for yield, and really the focus for us in the thermophilic space, you can see in the digestate numbers, you get a very, very small amount of dry weight equivalent in the digestate stream, and that's because it's a highly efficient process. Almost all of the carbon is being converted into a gas stream, and that makes it really, really exciting for us. Moving right along, you can see also that means that the digestate sales become a really small fraction of the dependency in the revenue stack, and that's an important thing for financiers as well. Obviously, there's opportunities with biogenic CO2 to look at co-location. We've probably all heard the story about P2X and e-fuels, SAF, diesel, methanol, even synthetic natural gas. It's exciting, but we really need that scalable hydrogen to be available in the market at a competitive price to make that work, and that's still some time away. Renewable protein is emerging as a really interesting opportunity. 44% of habitable land globally across the globe is devoted to agriculture. And a large chunk of that is devoted to the support of livestock, so animal feed and livestock production. So a huge proportion of our agricultural sector is there just growing food for animals, basically. So if you can actually supplant that with protein that is synthesised on the back end of a biogas plant, you can free up huge tracts of agricultural land that's otherwise got to be devoted to that animal husbandry process. Finally, BECCS I think is really interesting. In the European Union, for instance, you can see Ørsted's Avedøre power station in Copenhagen. They are bundling the biogas post-combustion capture with Kalundborg on Western Zealand in Denmark, and then looking to bury 450,000 tonnes a year of biogenic CO2 essentially offshore in the North Sea. So this is happening, it's happening at scale. And in the absence of hydrogen markets or hydrogen coming online at affordable prices and large scales, it's the option that's available to actually essentially, as per the little illustration, to stuff the genie back in the bottle. At some point, we've got to find a way to net reduce legacy carbon in the biosphere as well. So I would add, and there's been some allusion to this already, that bioenergy with carbon capture and storage is seen by the IEA as one of the most critical strategies to achieving net zero by 2050, and it is the only methodology we have at our disposal to bury carbon effectively that also generates energy at the same time. So it's the only pathway for that. So finally, I would summarise by saying that revenue cross-subsidisation and diversification adds resilience to utility-scale biogas plants, and it's really essential to long-term competitiveness. We've got to find ways to monetise the co-products effectively. The environmental benefits are really multiplying when we do that, and that's exciting and can deliver net negative carbon outcomes, which is great. Renewable hydrogen means that synthetic hydrocarbons are a bit challenging today, but I think that's a much better use of hydrogen than using it straight, using it neat. But in the near term, alternate uses of biogenic CO2 are going to be necessary in order to support project economics for projects of the sorts of scales that we're dealing with by virtue of the volume of CO2 that we're generating. Thank you for your attention.
Afternoon, everyone, or almost afternoon. My name's Dylan Gower. Obviously, I'm one of the directors of Clean Bioenergy. I'm offering up a small-scale project, regionally based. It's been in development for quite some time. Some of you would have known me going back quite a few years. And also just acknowledging the support of colleagues in the space, and also particularly Bioenergy Australia for their work and advocacy in the space, particularly in the last couple of years, that really have advanced the conversation. So, I'm particularly going to focus on a project that we're developing at the moment. It's called the Clean COP, and it's specifically focused on the optimisation of a co-digestion process, a component that we really believe is a way of advancing, and as has been raised earlier today, advancing in terms of the potential for gas make for bioenergy. So from a regional perspective, I guess some of the key issues, I'm not going to harbour on this too long. The economics are predominantly driven, by resource and processing industries, and also specifically agriculture. And they all face very sort of similar issues that they are dealing with in terms of their operational costs, in terms of input, and increasing unreliability around the energy resources as well. I think also a key component is around the provision or the ability to access alternative waste services, and this is sort of coming to the fore, particularly for agricultural production. I think the specific focuses are associated with the emissions, and particularly for, once again, the agricultural sector, this becomes quite a critical issue. We spent the last 6 months sort of interrogating this aspect. We were lucky enough to participate in a grain innovate program put out by the GDRC. As we know, agriculture is facing two significant sort of issues in terms of their production requirements. One, in terms of the amount of waste that's actually produced from actually the actual undertaking of the process, and then also the reliance and escalating costs in relation to the fossil fuel inputs for production. As part of this investigation, we're looking at the potential for bioenergy to contribute to this, and firstly, sort of focusing in the particular area of crop production and the utilisation of residues coming from that process, and then later down the stream in terms of the actual food production once you got to the significant waste streams coming out of that part, and then the subsequent distribution as well. But I think in terms of in terms of the opportunity that we see from bioenergy is how it can potentially address a number of these issues in terms of providing a waste solution, particularly from a regional perspective where a number of waste streams can be aggregated and increase the potential for the utilisation, particularly at a precinct or a district scale. Also the development or utilisation of existing infrastructure for distribution, and I'll go into that a bit more detail. But I think most importantly is around producing local products that have a significantly lower impact in terms of their emissions abatement component, and then feeding back into that around the circular opportunity for a number of associated industries. So what does a large-scale facility look like? In a joint development between Clean Cara, which is our community organisation, and Clean Core, which is the development wing, we developed a detailed business plan going back a couple of years, established for a major grant submission to the New South Wales Government. We continue to work with our project partners to establish investment into the project delivery. Unfortunately, during the process, as we all, as developers know, the goalpost got moved a little bit, and unfortunately the associated grant funding was no longer available. We're working with our local network distributor, so that's Jemena Gas Networks. Through their encouragement, we look to scale the initial development where we're working predominantly behind the meter, interfacing with a number of key industry parties, mineral processors, food processors, and also metal fabrication that existed within an existing precinct. And through the development of the business case, we identified that there was a significant opportunity to look for injection into the network, whereby in a unique situation, we could effectively decarbonise the whole of a local network. So any participant in the gas network, whether it was industry, business or residential, were effectively put in a position where we'd offer a significant decarbonisation opportunity. In conjunction with that, we were also developing an embedded network, an electrical distribution network within the precinct, whereby we would be able to utilise any additional gas for electrical generation. Just an interesting correlation that we've established, and I'm sure many of the developers have looked at this, in our mapping and looking at the scaling opportunity around where these plants could additionally be. There's an interesting correlation between the eastern seaboard and the growing cropping regions, which you can see on the right-hand side in the green, and also the overlay of that in existence to the existing infrastructure network distribution opportunities as well. And this was why it also helped us interrogate that idea around how we could potentially integrate to the existing network. So how does it work? I guess the key focus, has been discussed before, is a shift away from more linear processing, particularly from an agricultural perspective, where significant inputs, you produce a project and there's a significant amount of waste post-product. I think that occurs in a number of the other associated processing industries as well. Identifying that by doing so, providing a centralised approach whereby a number of resources could be aggregated, we can actually turn the dial on that in terms of actually starting to introduce some circularity, utilising existing thermal networks and creating new network distribution through the likes of embedded networks. I guess effectively decoupling the market, decoupling the valuation through market fluctuations by effectively creating a more circular approach to the project. So what is the Clean COP project? It's a demonstration. I guess the key focus has been on maintaining momentum for the project development, identifying a need for a live on-ground application for bioenergy within the Central West New South Wales. The initial steps bring a small-scale digester to Cara, and by doing so we can address some of the sort of key areas of investigation that will help determine some of the environmental, economic and social impacts that relate to bioenergy projects. So the support that we've been able to attain, as I mentioned before, we participated in the Grain Innovate program, supported by Cicada Innovation, a local incubator program, supported also through the CSRO. Through that, we sort of interrogated the exploring a path to market, particularly of projects of this scale. During that investigation period, we also identified an opportunity to participate in an innovation challenge that's been put up by one of the regional universities, CSU, through their AgriPark innovation program. This was also supported by Food Agility and Race 2030, who've heard of before. they've developed an opportunity assessment specifically in the bioenergy space, and obviously very supportive of this investigation. For this particular pilot, we've established a joint venture arrangement with Biogas, a technology provider out of Queensland. And the reason for that was that they've developed a small-scale application for biodigesters, whereby a number of substrates can be put through the process. You take it from, I guess, a lab-scale application and develop it to, I guess, a more demonstration-scale opportunity. I guess it's around the valuation of the input requirements, establishing the opportunity for direct substitutions for agricultural inputs for both fuel and fertilisers as well, and then look at establishing some of the specification and compliance requirements for the nature of the outputs. I won't harp on the next bits. It's been covered quite heavily during the discussion, but I guess probably the key focus is around that aggregation. So within the Cowra district itself, there's ample biomass in terms of that aggregation. It also offers, I guess, a variety of waste that then feeds into the opportunity around what we've raised before, is around the co-digestion opportunity whereby greater yields of gas can occur, and also, as raised by a couple of speakers as well, the nutrient makeup in terms of the digestate post-processing. Although the utility scale, although the throughput of a facility like this is only about 1,000th of the scale of a utility scale, I think it's going to offer some significant data around the optimisation of the gas make, as well as that nutrient stream. I think, as raised before, I think it's Scott who raised as well, the necessity for these projects to have multiple revenue streams as well is really key. And the deployment of these facilities in order to obtain a path to market needs to address the multiple aspects of this. We see probably biogenic nutrients as a key component of it. At the moment, in most modelling, digesters are nice to have. It obviously commonly valued as either a sort of a high-grade compost value, but we think we can dial that up in terms of some of the exploration, working very closely with a mineral processor around what that may look like as well. So just very quickly, just touching on the potential, some of the analysis we did in terms of the potential market scale for this. What that may look like and what are the opportunities that these sort of projects present. This is specifically focused on the potential serviceable market for organics and inorganic sector, and what fertiliser as an additional revenue stream may look to, like projects of this scale. So yeah, once again, just thank you for this opportunity. We certainly, it's been a long journey, but as raised before, it requires the collaboration of multiple parties, both from government, from industry, and also from the financial sectors to get projects like this. And so they have very long development pathways, but I think with the collective approach and certainly the momentum that's building now, I think we can go a long way to actually delivering some of these projects this year. Thank you.
Thank you, everyone. I'd now like to invite the panellists to come and join me on stage for a Q&A. Minus the Queenslanders, yes. Thank you all so much for what was an incredibly informative session that, I think we learnt so much, and we have, including this morning, what we've seen is there is a huge amount of potential supply of feedstock. We are seeing thriving markets overseas in Europe and the US. There are hundreds of plants already in existence, thousands of plants currently under development overseas. There's obviously proven technology. We've heard about, the opportunities to optimise that value. We have also heard that what we need to do to make the Australian market start moving is policy. I'll talk more to that later on this afternoon, but we see that developing as well. But I have a question. We have investors, who have opportunities to invest here or overseas. Why would any of those investors invest in Australia right now?
Yeah, I've got one for that. Most of them, they wouldn't. They see the market as too high risk. There's a lot of barriers that they could just deploy their capital in other markets with a much less risky outlook for return.
So what do they need to see? What would help them feel more confident in the market here?
I can throw my 2 cents
and then
in.
I think Joe's after you. Yeah.
Stability and bilateral, kind of policy is important. So over the long term, we are, to that point, we are competing for capital in this market with other far more progressive biogas markets, I guess, even in the Asia-Pacific region. India is going gangbusters at the moment. Even Indonesia actually is mobilising very quickly with the right policies and incentives to drive growth. So definitely stable policy and the right incentives targeted to stimulating the sector are very, very important.
Okay. Joe?
Yeah, look, can you hear me? Yeah.
Yep.
So for us, we have been successful in this space. So, and I think that's mainly because we've had a commercial lens. We've focused on the outputs. We've focused on the capital expenditure, the OPEX. A project, these types of projects aren't when the sun shines or the wind blows. It's a business. It needs the support of the business. It needs to understand how to make a facility profitable. Technology definitely comes into play, but when we look at the learnings from Europe, it's more about how we pull the levers to capture. I think Dylan spoke about some of the digestate, but getting that into a contract that enables an investor to support and back, so that we're not just focused on waste or policy is probably the main factor behind it.
Great, thank you. Dylan, we heard about these regional decentralised solutions being different to potentially metro options. What are some of the opportunities and some of the challenges of doing regional projects versus metropolitan ones?
I think it relates to context, predominantly, obviously. But I think the discussion point is around scale. So I think in terms of metropolitan applications, obviously accessing feedstock and availability is either very immediate or very disparate. So the ability to actually secure that in a regional setting has a slightly different approach, whereby within a district, say, 30, 40 kilometre radius from a certain centre, there's actually quite ample biomass there. So the approach is really around how best to structure that and how best to aggregate that. So I think it's a slightly different complexity. We also don't have we have a diversity of feedstock, but then probably from a regional perspective, I guess less focus on the likes of FOGO. So we're more on the distribution end of agricultural production side. So it's really around that aggregation and adding value through the co-digestion of that.
So on that, Disong, I want to ask you, is it common to use multiple types of feedstock in what you're seeing with the various technologies that you use? What are the important technical considerations in designing a plant that does that co-digestion?
Yeah, I would say if you look at the business model of a biogas power plant, you have the supply side and demand side, and in this case, the supply side of the feedstock is so important to achieve the economic scale. And also, if you are providing a recycling solutions to the customer, the reliability of continuously taking the material is very important. So the whole design of the plant must allow multiple feedstock to come in and to achieve the chemical balance, and also must have the reliability that you don't shut down the waste collection part of the business of your customer. So it's in our experience, it's always a practical approach to design for multiple feedstock, so that you have reliable supply of feedstock, and to maximize the efficiency, and also to provide a good quality of service from both the front end to the waste generators, also to the user end for the supply of fuel.
Thank you. Are there any questions from the audience? No? One down the front here. Thanks, Adele.
Levent Hilmy from AGL. I just wanted to get the panel's opinion or risk mitigation around feedstock supply, and what role do you think the waste collectors like the Cleanaway, Veolias, Ramonas of the world, what role do they play in the whole logistical side of supplying feedstock to these cogeneration plants?
Long-term contract.
Yeah, from my experience, it's really hard for them to commit to long-term contracts, and they'll just basically go back to back with their contracts. So you're looking at, maximum five years. How do you mitigate that risk in the longer term for the return on the project?
It's a tricky one because essentially those are the numbers that form the model that you're basing your projects on, and it's, I guess, building in variability in your supply. So, like he was mentioning before, it won't be just one, say, aggregator contractor that you're supplying. It's multiple feedstocks or feed sources. So. With a particular project, we're developing 95,000 tonne capacity. It's not just councils and some aggregators. There's a lot of other sources considered to build that model.
Just to add to that, the Australian market is a merchant market for feedstock, especially in the if you like the contaminated waste space where Cleanaway, Veolia, and others operate in. So it's more about the independent reports, it's more about the volume of waste in the area, it's more about having multiples of that being the lowest cost of disposal outside of the landfill levy and incentivising in that way. The facilities that we've built have all been filled up within 6 months operating, but getting an investor over the line and comfort around that takes a lot of time and a lot of money, basically. So it's that's the hard part about this industry compared to the UK, Europe. I think more policy around driving organics away from landfill creates more opportunity for more infrastructure to manage and tie into that circular economy.
So in the long term, have you thought about the value of feedstock actually going up? Because a lot of these feedstock suppliers are looking and saying, well, now this is a resource, over time it'll be more expensive to find the feedstock. Is that built into the financial model of your projects?
I think good luck getting an investor over the line that feedstock's going to go up. I think you've got to, when you look across at the European and UK markets, feedstock has come down. So there's a lot of concern that a gate fee model is going to go to zero and past because of the way that is operating. A lot of UK operators are buying feedstock, so but that's because you've got a clear policy in that supports the purchase of that feedstock. So without clear policy means that we've got a gate fee. With landfill levy, it means we've got an opportunity, and it's about driving those points to meet a investor return and giving confidence around that.
I want to comment on the point about the waste-based feedstock. One possibility, instead of like having a contract with the waste management company, you could have a contract with the city, because they are the ultimate owner of the waste, and they're going to have the waste for long term, and they need a solution. This is what we see happening in many of the projects we have done. The tender is actually called on municipal level. So the city sign long-term contract with you for waste recycling solution. The waste collector and the transporter is just the service provider to deliver the material to you.
Can I add to it?
Yeah, go.
I think it's also about diversification within your model. So some may be gate fees, some may be merchant, and then some may be on contract. So really creating a mix around it. And I think also if you looked at some of the earlier modelling in the German context, there was a lot of focus around the utilisation of energy crops, and that was basically to create a baseline. And as the technology, or as the market has matured, they've tempered down on that as more and more waste streams come online. So I think it's around a progressive approach and a gradual transition, rather than saying what you locked in now for a 5-year term is going to be the same substrate that you're going to be using there. And the nature of the tech is that you can modify as it matures.
We have a completely different model altogether, in the sense that instead of looking at diversity of feedstocks, we go the other way. And the reason we do that is twofold. One is for farmers, they want long-term contracts for offtake of their feedstock, because for small aggregated farmers, small in the Australian context, no offence to our German friend here, 1,000-hectare farm, you know, these guys have an annual headache about what the hell am I going to do with all of the straw I got sitting on my paddock. If I can't find a buyer for it this year, how am I going to get rid of it? So in the absence of a market, they either over-till it into the soil or they set fire to it in the paddock. Now, it's not illegal to do that in Australia as it is in the European Union yet, but for us, there's not a lot of competition. We're not dealing with multinational waste management companies that have enormous market power. We're dealing one-to-one through aggregators with farmers, and we're solving a problem for them. And the benefit of dealing with that type of feedstock is it's homogeneous. With minor variations, it's the same day in, day out, right? You can stockpile it, you can bank it, and we think it's a different paradigm, but it means that you don't have to worry about variability in both feedstock quality and characteristics, and therefore you have a more stable gas yield.
Thanks. I think it's really great to hear that there's actually not a one-size-fits-all kind of model approach to this. We do need a variety of different solutions, a variety of different technologies to bring all of this to market. So that was great to hear. Any other quick questions? I could keep going for ages. There's a question up the back.
Just a quick question. The carbon dioxide part of the biogas, are there any incentives to utilize and reuse it?
You mean in Australia or where we do it?
In Australia.
That I'm not aware of. Whether there's any incentive on utilizing the CO2 coming from the biogas plants. But maybe just quickly sharing how it works in Europe. So it was mentioned that we get, what did you say we have in Germany for the gas, somewhere between 60 and 90 euros per...
90 and 120 euros per megawatt hour.
Yeah.
40, 50
That's of course not necessarily the cost of producing biomethane. Feedstock suppliers, like in our case, for example, chicken farms, know what we do with it. So we have to pay a matching price for the chicken manure, where in Australia sometimes you actually receive a gate fee. So the price that we get for that LNG is driven by the carbon footprint of the LNG. And one huge contributor to the value we get from liquefying and using the CO2 is because it also reduces the carbon footprint of the LNG. So the carbon credits we get on the LNG pay for the liquefaction of the CO2 in that case.
To answer the question, we don't really have an incentive at the moment. I think it's more about what does the opportunity look like, and I think, you know, there's been some whispers or discussions I've heard around the traps, even during this conference, around the possibility of actually certifying biogenic CO2 streams. So actually, in addition to the biomethane stream, being able to actually bank the quality, if you like, from a carbon neutrality perspective, you can emit it to atmosphere, you know, without any problem, because it's considered part of the carbon cycle. But equally, it is a resource. If you're going to do something productive with it, then again, just like a biomethane user, you want to be able to demonstrate that benefit and quantify that reduction or displacement that's occurring. So I think to the guys at Green Power, Brad, I cornered you yesterday. I think I made that comment. I think it'd be fabulous if there was a way for us progressively in Australia to lead the world by certifying the biogenic CO2 component so that we can trade and use that in more productive ways.
Brad, did you want to add anything to that? Can we get a microphone?
Didn't mean to put you on the spot, mate. But.
Sorry. Not to put you on the spot, but
I kind of did.
Yeah, you kind of did. That's okay. No, really good discussion, and we do see value in potentially certifying biogenic CO2. Right now, there is demand for it, but we do see over the coming decade that demand increasing, especially with renewable fuels or e-fuels, I guess, coming to the fore, forecasting over the next decade or so. I think that'll support that. So we'll see a kind of a dual approach where we'll be supporting biomethane development as well as renewable fuel development. in addition to supporting decarbonisation of food and beverage, other industries like construction, etc. So it's something that we are investigating right now pretty seriously, and I think probably by the middle of year we should have some sort of outcome that we can sort of share with everyone on that. Yep.
Wow. There's another question over here.
Yeah, I had a question. In the presentations, they said in the EU and the US market needs about $40 a gigajoule incentive to drive the market. Do you see that requirement being higher or lower in Australia, and what would be the key difference in what's needed?
We'll take anything at this point. Does anybody have a specific view rather than me throwing gags at me?
Like I said before, same as with the German price or the French price, those are not necessarily the production cost for biogas, so it's not necessarily required to have that level of pricing. But we certainly need some incentive and security in there being a market. Like, for example, even a penalized minimum and increasing quota in the gas grid would be helpful. That's what's driving the market in Japan right now. We have projects that are designed to export bio-LNG to Japan. Why? Because in Japan we expect to have a renewable gas quota in the grid that's increasing. There is no set price, but we know what projects will be the most competitive ones to meet that, to provide that gas, and that makes those projects viable. Of course, a viable, predictable, fixed long-term price, as we have it, for example, in France, will be the fastest trigger to get projects off the ground, and maybe that's also what would be useful in Australia to kick off developments. I also want to add one thing, just in case nobody's asking. There have been several presentations yesterday generally on biofuels, encouraging that we should rely on consumers to prefer carbon neutral products. My opinion is that's delusional. A friend and I, we did a poll yesterday, and we found that 100% of the participants would not voluntarily, for example, pay the extra for a flight ticket. That was a sample size of 2, but I think I think if we increase that sample, we get similar results. It's the same as nobody would voluntarily pay a road tax or voluntarily pay for road sweeping services. That's something that a society has to do together. So that really requires regulation. Otherwise, it's not going to happen.
I was just going to say, I think it's about risk and it's about certainty, and wherever that setting is, I think it just needs to give that line of sight for investors that the rug isn't going to be pulled out under their feet. So it's got to drive the right outcomes, and I think, can I say, is it going to be higher or less than that? It's not for me to say, but certainly having some incentive on the table that gives certainty over a longer period is important to particularly get the first tranche of kind of scalable projects away. Otherwise, it's going to be tough.
Without putting Brad on the spot again, people are aware, obviously, with the REGO system, there's a value that adds to your benefit in terms of producing renewable gas. But at the moment, because it's relatively new and not mature, there's I guess a range of indication. And until the sort of market sets that price, it's a bit of an unknown quantity. So it's a nice to have, but it's not quantifiable at the moment.
Thank you. We've actually run out of time. I know I have more questions. I've seen there some questions have come through online as well. I'm not sure, I can't see many people in the audience. Carl asked a question. Carl, let's catch up at lunchtime so I can answer that question. I did want to ask a question, but I'm going to encourage you all to talk to each other. There is ample feedstock out there, and we know the demand is there and the need is there. We can see that Delorean have got projects up and across the line. We know there are a number of other projects that are currently in that process of working towards FID. I assume that apart from policy, there are probably other challenges. We've heard about permitting, approvals and other things. I encourage you to talk to each other and go pick Joe's brain on what were some of the challenges and how did he overcome them, and let's all learn from each other and collaborate. This is not a point for competition. There's plenty to go around. Let's work together. Thanks, everyone.